Welcome to this new video in which we're gonna compute some derivatives using product and quotient rules. So let's start with the first one. F of x equals x exponential x, and here we can see that it's a product of two functions, x and exponential x. We're gonna use the formula u times v prime equals u prime v plus u v prime, where u and v are two functions of x. So let's apply this to f of x here. U is x and v is exponential x. So f prime of x can be written as the derivative of x is 1, so it's 1 times exponential x plus x times the derivative of exponential x is exponential x, and we find that it's exponential x times 1 plus x after simplification, okay? Next one, f of x is x ln of x minus 1. We have a first function here, x, a second function, ln of x minus 1. So we're going to use, again, the product rule. F prime of x is, the derivative of x is 1 times ln of x minus 1 plus x times, and the derivative of ln of x minus 1 is 1 over x. So let's simplify. We're going to obtain ln of x minus 1 plus, and x times 1 over x is 1. So we can cancel the 1, and we're going to obtain ln of x. So the derivative of f of x here is ln of x. Next one, it's 8x to the power of negative 2 ln of x. Again, here it's a product, so we're going to apply the product rule. Okay, so f prime of x is, we can keep the 8 outside of our computation and apply the product rule to x to the power of negative 2 ln of x. So the derivative of x to the power of negative 2 is negative 2x to the power of negative 3 using the power rule times ln of x plus x to the power of negative 2 times the derivative of ln of x, which is 1 over x. Okay, so it's equal to 8 times negative 2x to the power of negative 3 ln of x plus x to the power of negative 2 times 1 over x is also x to the power of negative 3. Of course, here we can put x to the power of negative 3 as a factor, and we'll obtain 8x to the power of negative 3 times negative 2 ln of x plus 1, which is the simplified form of f prime of x, but of course you can stop here or here. All of them are correct. Now, fourth one, here we have a quotient, okay? A quotient of two functions, and we're going to use the quotient rule, which is u over v prime equals u prime v minus u v prime over v squared. Okay? U is 3x minus 4, v is 2x plus 3. So let's apply this formula, and we're going to obtain f prime of x equals, the derivative of 3x minus 4 is 3 times 2x plus 3 minus u v prime, it means 3x minus 4 times v prime, which is the derivative of 2x plus 3, which is 2, over v squared, it means 2x plus 3 squared. Now, we can, of course, expand and simplify our expression. We're going to obtain 6x plus 9 minus 3x times 2, which is 6x, and minus minus, it's a plus 8, over 2x plus 3 squared. Of course, we can cancel the 6x here, and we're going to obtain 17 over 2x plus 3 squared. So this is the final result for the derivative of f of x. Next one. Again, we have a quotient. We're going to obtain f prime of x equals, the derivative of x squared plus 1 is 2x times 2x minus 3 minus x squared plus 1 times the derivative of 2x minus 3, which is 2, over 2x minus 3 squared. 2x times 2x, 4x squared, minus 6x minus 2x squared, and minus 2 over 2x minus 3 squared. Of course, we will group the similar terms. We're going to obtain 2x squared minus 6x minus 2 over 2x minus 3 squared. Next one, f of x equals 2x over 1 plus ln of x. Again, here it's a quotient. We're going to apply the quotient rule. F prime of x equals the derivative of 2x is 2 times 1 plus ln of x minus 2x times the derivative of 1 plus ln of x is 1 over x over 1 plus ln of x squared. It's 2 plus 2 ln of x minus 2. 2x times 1 over x is 2 over 1 plus ln of x squared. We cancel the 2, we're going to obtain 2 ln of x over 1 plus ln of x squared. Next one, number 7, which is 1 minus exponential x over 1 plus exponential x. Again, here we have a quotient, so we're going to obtain f prime of x equals the derivative of 1 minus exponential x is minus exponential x times 1 plus exponential x minus 1 minus exponential x, and the derivative of 1 plus exponential x is exponential x. We are applying the quotient rule over 1 plus exponential x squared. We can here expand and simplify, or put the exponential x as a factor, okay? I will put exponential x as a factor. We can put negative exponential x as a factor, so the remaining quantity in the first term is 1 plus exponential x. The remaining quantity in the second term is 1 minus exponential x plus 1 minus exponential x. Don't forget that we put negative exponential x as a factor, so this negative sign goes with the negative exponential x as a factor, okay? So over 1 plus exponential x squared. Here we can cancel the exponential x, okay? And we're going to obtain 2 times negative exponential x, which is negative 2 exponential x over 1 plus exponential x squared. We are done with this list of functions. We made the derivative using the product and the quotient rule. Thank you for your attention, and see you in the next videos.